If you've ever worked with JavaScript, you've probably come across the atan2 function. Maybe you are dealing with angles or rotations, or trying to figure out the direction from one point to another. But what exactly does atan2 do, and why do we even need it? In this video, we're going to break it all down. First, we'll take a step back and look at where angles come from, and what the tangent function actually represents. Then we'll move on to arctangent, also known as the inverse tangent, to see why atan doesn't always give the right answer. And finally, we'll look at how atan2 fixes everything, making it the go-to function for calculating angles in any quadrant. By the end of the video, you'll know exactly when and why to use atan2, and you'll never second guess it again. So let's dive in. To understand tangents, we need a visual. This right triangle is the perfect starting point. Imagine a triangle where one angle is 90 degrees. The other two angles depend on the lengths of the sides. The key thing to focus on is how the sides relate to the angle theta. We have three sides: the opposite side, which is the vertical distance or rise; the adjacent side, which is the horizontal distance or run; and the hypotenuse, the longest side that connects them. The tangent function, tan of theta, is just the ratio of the opposite side to the adjacent side. This ratio is useful because it tells us the steepness of the angle. A bigger ratio means a steeper incline, while a smaller ratio means a gentler slope. But what if we already know the ratio and need to find the angle? That's where arctangent, or atan, comes in. It's the inverse function of tangent. It takes the ratio and gives you back the angle. Now here's where things get tricky. Atan only works in certain cases because it doesn't know which quadrant the angle is in. See, when you divide two numbers, you lose information about direction. For example, 10 divided by 10 is 1, same as negative 10 divided by negative 10, which is also equal to 1. Both give the same result, even though the points 10 and negative 10 and negative 10 are in completely different quadrants. This means atan gives the same output for two totally different angles, which is a big problem when working with rotations or directions. That's where atan2 comes in. Instead of just dividing y by x, it takes both x and y separately, keeping track of their signs and using them to determine the correct quadrant, thus giving you the right angle no matter where you are on the coordinate plane. Thank you for watching, and if you learned something, please consider subscribing to the channel.